Okay, so this video will be on density, just as I said. So this is video 2 of the fluid statics video series, so it will be official, because the introduction doesn't really count. Well, anyway, so last time we talked about pressure and equals force over area in the simple sense, and now we're going to talk about density. And density is essentially mass over volume. Kilograms per meters cubed is usually the measurements. And that's the typical measurement, as I said. So, but also for gases, the density is actually dependent on a lot of factors. Actually, the equation is the moles of the gas, which we'll talk about soon. Moles of gases, we'll do a lot of examples of that. And the pressure, then we have the ideal gas, which is also ideal gas. Sorry, the gas constant, which we'll also talk about in the coming videos. And then we have temperature. Um, anyway, so that just gives you a little illustration that gases and liquids do not necessarily obey the same laws. Their volume and things like that. That's and density. That's all. It differs. It differs from fluids to gases, and we'll talk about that. We get a little more advanced. But anyway, so essentially we have force. I said I'll do a practice example. So let's we have force over area, and we have, let's say our force is 20 newtons, and we have over a area of 5 meters, just for simplicity's sake. And then we have pressure is 20 over 5, as we plug in F, and it's 20 for the force, and then area is 5, and then we're going to get 4 newtons per meter because of the units and all. And of course, pressure is a vector quantity, as is force. A vector is something that shows magnitude and direction. For those of you guys who haven't studied necessarily physics in great detail. But anyway, so simply from this video, know that gases and fluids densities are different. They obey different sets of equations. Although fluids and gases share more similarities than solids do. Solids with fluids and solids with gases, etc. Also, we talk about plasmas later on. Plasmas are essentially the fourth state of matter. They are ionized gases, gases that have not the normal amount of electrons. Anyway, so this video is just densities, mass over volume. Gases obey a different set of equations for this, and pressure equals force, the net force over area, and essentially, going back, let's say before, fluid statics, widely used in engineering, especially with rockets and planes and things like that, and so it's just interesting. I would say a fluid mechanics is probably the branch of mathematics that sort of has the most applications. Because engineering, just a pure study of physics, a lot of gases and basically so many things can be built using laws of fluid mechanics, and so many physics laws are similar to fluid mechanics. And you can derive a lot of similarities from let's say electromagnetism, and sort of like it's to fluid mechanics. There's a lot of similarities, so it's widely applicable. It's sort of like it ties a lot of areas together. There's also computational fluid mechanics, which is all about using computer algorithms and things like that to model temperature. I mean, so sorry, weather. Spin of hurricanes, storms, things like that are all could all be done these days. Well, not all of it, but I mean like use fluid mechanics, things like that, pressure, and you could estimate what's the next storm going to be. So fluid mechanics is very widely applicable, as I said before. So that's all for this video. I'll be making the next video a little later on. So yeah, hope you guys enjoyed. I'm cutting the video series short for now. Anyways, till next.